doing more C programming, C basics. We're going to walk through this list. We did some of these items yesterday. Function pointers, strings, passing data by reference, structures, and unions. We'll play around with some unions today. This will be interesting. I'm actually kind of excited about this one. Macros. I've only written a few macros that I've used throughout my time with C. I typically don't really ever have to need to use them because I've kept everything really simple. Here, lifetime. It looks politically text related. All right. Memory. All members share the same starting memory address. The union size is equal to the size of the largest member. I mean, shouldn't it be the size of the collection of the members? I feel like it should be the collection of the members. Not. That might be some hallucinations right there, you guys. It might be hallucinations. You never know. Access members, dot operator, sounds good. Or the arrow operator. You can do either. You can? Let's mess with it. Okay, let's do some unions. Let's try. Well, at least get that going there. All right, Q, exclamation point. All right, LS. All right, so CP main to union. Let's do union.c. Union. All right, get rid of some of this. / star, go. Next, delete. All right, let's get rid of this. We don't need that anymore. We only need the main function. All right, there we go. Return 0. Copilot disable. So we don't do that. All right, so let's do a union. We'll call it data. And we'll say, I don't know, name. One second. Like enumerations. We are going to do enumerations here in a little bit. We'll do a union. We got a union. And we also included type def, so it's nice and pretty. Linux is less user-friendly. Also, more in code for coders. You're right, yes. It is more for coding. WSL, Windows Subsystem for Linux. Thank you, Anthony. Thank you. Yeah, so you know what? Good news. You can choose Windows and you still get Linux. So it's perfectly fine. It doesn't matter anymore. Everything's everything now. It's all merged together. Thank you for the heart. Thank you for the floaty heart icons there. I see it floating up there on the screen. All right, so now that we've used a union, what do you do with it? Like, why is it different than struct? See, watch this. All I have to do is do this. Struct. Save, rebuild, run. Check this out. So struct and union, identical. What is the difference? Let us learn. I've only ever used struct. What is a union for? Why am I here right now? Why am I here? Let's go like this. Like that. Go back over here. Okay. Let us see if we get more information. Keyword, similar to struct. All members share memory starting. Access members using the dot operator or the arrow operator. Doesn't matter. Okay. We're doing it either way. Union. Okay, so interesting. All right, so let's keep looking here. I'm actually really curious about this. Windows Subsystem for Linux is slow. Is it? So it's like it emulated. It's not as fast as natively run, is what you're saying. Some people say coding is hard, but it's actually hard. I mean, you're kind of seeing what we're doing here. We're kind of figuring things out. It's a lot of reading, right? It's a lot of reading docs, typing in things, reading more, testing it with the compiler. Does it run? You know, that sort of thing. And it does, or it doesn't. Sometimes it crashes. And so we're trying to figure this out. Value to one member makes the values of the other members invalid. So, okay, got it. Understood. Now, this should be at the very top of the screen. This is what a union is. A union, this is what I thought a union is. It's one of these things. It's sort of like, this is kind of neat. Check it out. Actually, it's pretty neat. It allows you to define a data type that is a multivariate data type. Kind of. Not really. Not really. It allows you to say this is either one thing or the other. And so I'm kind of curious about that here. It can either be one but it can't be both. So if I do this, my_data.level equals 100. and then I try printing, what is going to happen here? What's going to happen here? According to the documentation, this should cause a problem. What's going to happen in this C basic when we are looking at the union? And we are not using a struct, we're using a union. Only one of these data is valid at any moment. So now that we've override this and we try to print data from name, doesn't that say it should be broken? Something should happen there, right? Let's try it. Oh, weird. Oh, interesting. Look at that. Oh, isn't that neat? Okay. That is unexpected. I understand it, because guess where D comes from? Guess where D comes from? It comes from this value right here. D is the ASCII for 100. 100 is the ASCII for D. That's what that's about. That is so interesting. That is so interesting, and I don't know why that would be useful. So we're doing unions, Neva, because you mentioned unions. I remember yesterday, you're like, hey, we should do unions. I've never really needed to use a union, and it's also very weird. I think, though, if we did a struct for either of these options, I think that would be more interesting. I feel like it's a little bit more interesting. You got a warning on error? Yeah, because I was messing. I was like massaging it. I'm like, hey, can I get the syntax that I want? The answer is no. You can't. Even though in a union, you can only have one active data type or one active member of your data here at any one moment, it is very odd that you still have to use directly the name of the member. I feel like it would be much nicer if you didn't have to use the name. If it was just one, although I guess there's some confusion there. It's just odd. I just think it's odd. You know what? There we go, though. There we go. I think it's just very weird. I think it's very weird. Although I think this demonstrates it pretty well. What if we did a struct, though? Let's do struct. Oh, you know what? Can we do a struct inside here? Struct like this. Let's go like this. Struct, and then we'll say happiness. We'll do like a char happiness, and it will be another 20. I'm curious about this. I'm curious about this. That'll build, right? That'll build perfectly fine. Hello, sir. What's up? Good to Shriel. We're doing good. Thank you for asking. Thank you for asking. Union is a way to save memory. It's exactly like you struct less memory. Oh, you would use them like Rust enums by adding a C enum as a tag. Interesting. Note has no idea what's in there, just memory. No idea which member is stored. Got it. That is pretty neat. That should build perfectly fine. So now that we understand, so if we can do an enum, we can do our own enum, right? So we can do enum if we want. We could do also type def enum. And we'll go over here and we'll have different types and we'll call it our type. Well, let's see. I mean, just type. Well, let's call it a type. Do we need a... We do. Okay. So we'll say int. And then we'll also say... Can we do commas? Yes. And we'll say stir. Right? Do int and stir. We're going to do that. We're going to be doing those two. So we'll do an integer and a string. Because we want to do level name. So we keep things happening here. Get rid of this. Well, we could keep the struct. I don't know if we need it or not, though. And then we could have a struct here. And we'll call this... Like in JSON, for example, if we're going to make some JSON, it has a whole bunch of different data types, right? And different nodes. So we could, with this pattern, it's pretty neat. And memory saving, we can create a union with a data type that has like string, array, object, lists, a whole bunch of things. That's pretty neat. Let's create our own simple. We'll create our own simple JSON, right? We'll create a simple JSON. So it's simple. String or int. That's it. That's all you get. No arrays, no objects, just string and int. So it's not really JSON. So we're going to do that. Here, let's pull this over here. I don't know if I want that. Okay. So we're going to do, so we'll do a struct and then we'll do a union in here. This will be a union. We'll make it a union. And then let's see here, union. And then we'll have our int I and then a char str. And let's say 100 or something like that. Right? There we go. So now we've got two data types. And then instead of having this, we'll delete that. We'll do an enum, and this will be a JSON type, something like that. And then we go over here. I think that's it, right? I think that's how that's going to work. I'm pretty sure this is syntactically correct. Pretty sure. Steven, can we do coding together? I saw you, Glock. Yeah. You got moderated, Glock. You got moderated. Hey, long time no tech, man. How's it going? Good to see you. Welcome on in. Happy to see you. We're doing C basics. I normally see you doing Rust or Python. Good to see some C. I know, right? And we are doing some C. That's the plan for today. We're rushing back up on our C. It's been a while, so I feel like it's good to do some C basics. And so we're doing in an enum with type def and JSON kind of. I'll do JSON kind of here. Sort of, kind of. JSON sort of, right? Let's bring this back over here. So it's sort of JSON, but not really. It's part of JSON. Integer and string. That's all you get. That's all you get. Integer and string. And then we've got a union and then the type of data. So this will be just that. And we don't need that anymore. All right. So let's pull this on over here. What I'm going to do is bring this down over here. Close that. Okay. So this is our full screen. Now we know what the difference between a struct and now it's good. Weird. Just so weird. It's like this is it gets the enumerator, the enumeration internally, this data value gets leaked into the global scope, which is very annoying. Probably not. Last time that didn't work. See, yeah, it doesn't like that. This is what it would be nice if you could do that, right? Although C wouldn't really know what to do there. Although it is defined right here perfectly fine. The compiler, if it wanted to, it could. It could figure it out. It could fully figure it out. So that's what I want. It's just not doing what I want, which is fine. So this works, and there we go. Now we have a fully working example with an enum, a struct, a union, and all in one file. Kind of an interesting C basic here. It's pretty interesting. And it's a little overwhelming because... And then so what we could do is we could write a switch statement here. And what is the switch statement? Switch statement is on the type. Something like that. Let's see, how do we do switch? I know there's a switch in here. Switch case, right? I forgot the case. Case, it will be a break. And then we'll call increment. We'll set it to 0. Equal 0. And how do we leverage this? Now we've got a static variable. This basically means that data within the scope, as far as I can tell, will remain, it'll remain whatever value we set it to. Increment ++. I believe there. C basics, we're going through a variety of C basics. We got functions, strings, structs, type defs, unions, enumerations, and we're doing static variables right now. So that won't work there. This will though. All right, isn't that neat? I think that's pretty neat. Versus something else. Let's do this without a static. Here, something else. All right, let's do that. We won't do a static though this time. And then we'll return. We'll do this. Also, I'd rather do this, so keep it on one line. So this will always return 1. So check this out. This will be neat. This will be neat. So do something _else. Java is good for learning because it's strongly typed. Hey, there you go. Strong data typing. Hey there, Judah. Good to see you, Judah. What happened if we write 2 different functions and each function has the same named static variable? We're making our way with C basics today, and I'm really excited to try this. All right, so we've got 2 functions, do something and do something else. Each function has variables defined, and one function we're incrementing a non-static variable, and the other we're incrementing a static variable. In this case, we're going to invoke each of them 5 times. We should see the output on screen should be 1, 2, 3, 4, 5, and then 1, 1, 1, 1, 1. That's a macro going. So we basically, I don't know why you'd want to do this. It's pre-processor stuff, so it can be valuable, right? So macro, from my understanding, is all pre-processed at compile time. Steven, check this out. Found Google this i3 pcom shadow. Don't you want that in your Linux? What is that? I don't know what that is. Far less. Too bad I started learning Java, the first language. Hey, it's okay. You struggled through the Java, and now you can go and yes, it's voodoo, and it's hard to work with. Sometimes I have to substitute with Kotlin. Yay, there you go. You're doing it the right way. You're using Kotlin. That's like the if you need to be in JVM world, hey, just use Kotlin. Just use Kotlin. That's the way to do it, I think. You guys. Why don't C# developers trust macros? Because they can't handle the expansions. Here you go. All right. Yep. So what is the value of macros? I think the value of macros is you can write functions or constants and things like that allow you to pre-process. You love macros over Rust macros over anything. Rust macros. There you go. Yeah, there you go. A function pointer walks into a bar and no one calls back. That's funny. I see what you did there, Heartwired. Okay, I stopped. All right. Vim or NVim? Vim. So I use regular Vim. Or Vim improved, right? Using Vim improved. Vim improved, you guys. I like Vim improved. Okay. So define. Let's do like add. We'll do like an add. We do x plus x. Wait. Let's do this. A comma b. So we'll add two numbers. A comma b. There you go. I think that's it, right? Will that work? Is that it? I don't know if this will work or not. We'll have to try it out. And then we'll see it. No. C macros are better than Rust macros. Oh, gotcha. Okay. You get a lot more option in C. Works. You wrap both A and B in parentheses as well, so they work if an expression. Okay, so do I have to do... We'll find out. C-lang macro. Out. Second here. -O. It built macro. Okay, all right. Well, you know what? That seems to have worked. Example, you can make a macro for appending to a dynamic array, and it would work for any style of array. Ooh, that's a nice one. That's very nice. Very nice. Now a sound, bro. I'm so lost. Hey, Nestor, don't worry. We'll see. We'll see if it becomes. We'll see if it makes sense. So we'll say int data. Let's a number. Let's do a basic number. Number equals add 1, 2. I think that's how that would work. So we define a macro. It's like a function, but not really. Let's see if that works. We went through a lot of C basics. We covered quite a bit. What did we do? We did unions, enumeration, static variables, macros, and a little bit more type defs and